Okay, so now we're going to go on to our last section in Chapter 6, which is called All Conics, and I like to call it which is which. So how do we know when we have the general form, so when it's not in standard form, how do we know which is which conic? So how do we know which conic we're dealing with here? So by the end of this, we're hoping that you can recognize conic sections by their equations, and you can write any conic section in standard form. So here are different forms, and this is kind of how the book shows it. And what I'm looking for is they kind of do this thing at the top, and you kind of need to see this right here to understand the A's and the C's. So in the general form, what they're saying is what really, really matters is what comes in front of your x squared and what comes in front of the y squared. And the idea is that you can pretty much ignore everything else when you're trying to decide what conic section it is. So for a circle, the A equals the C, all right? So they both have the same coefficient. So your x and your y squared have the same identical coefficient. In a parabola, you only have one x squared or one y squared. That's how they say one of them is 0. In other words, it's one of them's not there. So only a y squared or a x squared term, not both. Okay? In an ellipse, what you have is you have your coefficient for your x squared and your coefficient for the y squared have the same sign, but not equal. All right? So they are the same sign, but they're not equal. Because if they're equal, they would be circles. In hyperbolas, they have opposite sign, all right? So in other words, one of them is positive, one of them is negative. All right, and really don't worry about this one. We really just don't deal with this. It's kind of an inverse, and we're not going to mess with it. So those are really our 4 that we're going to be looking at. So let's look at some examples. Knowing that, which ones have the same coefficients that we were just talking about? Oh, well, that was the circle. Which ones have different coefficients, but they're the same sign? So either both positive, both negative. Parabolas. Different signs, all right? And it doesn't matter, well, they're not going to be the same if they have different signs, so they're different. Only an x squared term or a y squared term. That's the ellipse. All right, let's see that in play. Now, which is which, okay? Identify each conic section. Our first one. Well, I'm looking there. I only see a y squared. I don't see an x squared. So because of that, I have a parabola. All right? In my second one, again, I'm only dealing with my x and my y squared terms. That's all I care about. Here, they don't match, and they are different signs. When they are different signs, they are hyperbolas. In this one, I have a 27 for my y squared and a 9 is the coefficient of my x squared. So they're definitely not the exact same, but they're both positive. So because of that, they are, I'm blanking hyperbola, I was going to say parabolas are not parabolas, hyperbola, ellipses. Sorry, there we go. And then the last one, they are identical. The coefficients are both a positive 4, excuse me. So that means we have a circle. All right. So a lot of what we're going to do here is just kind of remind ourselves, what do we have, and then how do we put it in to general form? So I'm looking here going, well, what do we have? First of all, when I look at it, I have a 1 for a coefficient here and a 9 for a coefficient for the y squared. So that tells me they're different. I am going to have an ellipse. All right. For my ellipse, my process is I need to get my x's together, x squared plus 2x. I need to get my y's together, 9y squared minus 18. And the constants should go on the right-hand side. Now, if you can, you should factor out, and here there's nothing to factor out. We already have a leading coefficient. Here I can factor out a 9, though, and so I'd have y squared, sorry, this should be a y, minus 2y, and I have this. All right, and now I want to do the step where I complete the square. This would be plus 1. Here I go plus 1, but it's really plus 9 because it's 9 times 1. And so when I complete the square, I get x plus 1 quantity squared plus 9 times the quantity y minus 1 quantity squared equals 9. Now what I want to do is I want it set equal to 1, excuse me. So I'm going to divide everything by 9. In the end, my answer is x plus 1 quantity squared over 9. And then I'm adding y minus 1 quantity squared over 1. What I just did is I reduced this fraction here, 9 over 9 is 1. And it equals 1. That is my ellipse in my standard form. So what I know here is I can look at it and tell you my center, my h and my k. My center is at -1, +1. -1, +1. There's my center. From my center, I want to have 4 vertices. So I'm going to talk about my 4 vertices here. I'm going to go from my center, from the x direction, I'm going to go the square root of 9, or 3 units to the right and to the left. 1, 2, 3. Up, and actually, yeah, that's okay. I can just do that. I usually kind of do this. And 1, 2, 3, and kind of that. So my vertices here, 3 to the right of this would have been negative, or to the left, excuse me, would have been -4, 1, and to the right would have been 2, 1. So I just added and I subtracted 3 from my x values. And then the square root of this 1 here is 1 still, so I'm going to go 1 above, 1 below. So here's my 1 above, and here's my 1 below. It's kind of a long, kind of a weird thing here. So my other vertices, 1 above and 1 below here, 1 above would be -1, 2. 1 below would be -1, 0. Those are my 4 vertices. So here I can kind of graph my ellipse. I have like a long, thin ellipse there. Other things I would need to write for this one is my foci. Now my foci, you should kind of come over somewhere and calculate what is your c. And if you remember, your c squared equals your a squared plus your b squared. So c squared here is 10, therefore my c is square root of 10. And the c is the direction you're going to take for your foci. So if I showed my foci here, square root of 10 is a little bit more than 3, so 1, 2, 3. I'm going to be about here and about here for my foci. It's hard to see and it's hard to do on that graph. I think let's show it here. So 10 to the right, 10 to the left, or excuse me, square root of 10 to the left and to the right. We would start here at our center, and if I want to go left or right, oops, I guess I have to do that to my x, don't I, not my y. I'm going to say plus or minus square root of 10, and then my up or down, my y didn't change. So that is my foci. So that's everything I would need to show on an example of this. I need to kind of, it takes a lot of steps, but it's a good problem to work through. Okay? Let's do another one. Let's identify it and let's graph it. So when I look at this one, my x squared and my y squared match. So this one tells me, oh, I've got a circle. Same process in that I want my x's together, and I guess I already have my x's together here. I want my y's together, and then I want the constants on the right-hand side. And I'm actually going to take a minute here, and I think I can spread this apart. Oh, maybe. All right. And I'm going to add here to, I'm going to look here, and I'm going to try to see if I can complete the square. Here it'd be like 14, so what I want to add here is 16 to both sides. I kind of ran out of space there. Here it would be 3, so I'd add 9 to both sides. So now, when I complete the square, I'd have x minus 4 quantity squared. And then this would be y plus 3 quantity squared. And it would be equal to, this is 25, and a -24 would be equal to 1. So what I have here is a circle with a center at 4, -3, and my radius equal to the square root of 1, which is 1. So you're all going to be saying, please give me circles on the test, Mrs. Kennedy, because those aren't so bad. 2, 3, 4, down 1, 2, 3. So there's my center, and in all 4 directions, it's just 1 unit. So if we kind of, oh, that's not easy to do. So it's kind of close. It's a good sketch. Okay. All right, let's look here at 21. Now when I look at this, I have a positive y squared and a negative x squared. I have a hyperbola because one is positive, one is negative. But again, same grouping idea. We're going to group together my y's. I want to group together my x's. And I want to take any constants and bring them to the right-hand side. Factor out any leading coefficients. So here I'd have y squared minus 2y. I'm going to leave space for completing the square. I'm going to factor out my negative 9. I'd have x squared minus 4x. I'm going to leave room for completing the square. Now I have to complete the square, so this would be plus 1. So really over here I have plus 8. I ran out of space, sorry. Here it would be plus 4, but really it's plus a negative 9 times 4. So what I get here is 8 times y minus 1 quantity squared minus 9 times x minus 2 quantity squared equal, so that equals 72. Now what we need is we need it set equal to 1. And so we would have 72. We were dividing everything by. This isn't going to be fun to graph, I can tell. All right, y minus 1 quantity squared over 9 minus x minus 2 quantity squared over 8, and that's what equals 1. All right, so now I'm going to kind of do a quick rendition of graphing this. We'll start with the center point. It would be at 2, 1. So I'd be at 2, 1 right here. That's my center point. From there, in the x direction, I'm going to go square root of 8, which is a little bit less than 3, to the left and to the right. So 1, 2, 3, a little less. 1, 2, 3, a little less. All right, and then above and below it's 3, 1, 2, 3. There's my 3, 1, 2, 3. There's my 3. So you make your box. I know my box isn't perfect, but we're going to deal with it. So there's your box. You look at your asymptotes, and you're going to have to find equations of asymptotes here. I might have to pause this and come back. There we go. Because the y squared is positive, I know that this is going to kind of look like up and down. So my vertices here would be here and here, where we have our vertices up from our center point. I'm going to pause it, and some magical things are going to appear. So I apologize, I've run out of time here a little bit, but I wanted you to see what the graph looked like. I started with my center point of 2, 1, and the vertices, since it's a y squared, go above and below that by the square root of 9, which is 3. So I went 3 above, oh, and I'm even off there, and 3 below, 1, 2, 3, oh, and I'm off. This should be here. Sorry, guys, sorry. All right, so that should have been down a little bit, so my box is a little bit off. Oh goodness, there we go, that's better. It's now looking really messy. But the general idea is there, and this information is true. So here's our assignment. Check with Mrs. Kennedy for modifications. Definitely won't have, I'll have you just graph evens only. Graph evens only. Doesn't mean you have to do the odds, but the only ones you have to graph